All right, let's wrap up this chapter. Um, Osmotic pressure, again, we're dealing with controlling the number of microbes in an environment. Osmotic pressure, again, we just went over that. That was the last slide we went over in the previous lecture. So methods of chemical control. Chemicals can either be in liquid form, in gaseous form, or in their solid state. They can range from disinfectants and antiseptics to sterilants and preservatives. If they are if they are in a water solution, those are referred to as aqueous solution. Most of the things you are going to get in the stores are going to be aqueous solutions. Tinctures are chemicals which are dissolved in pure alcohol or alcohol water mixtures. Uh, Again, an example of an aqueous solution that you could buy over the counter would be bleach that you buy in the laundry aisle. That bleach it's called hypochlorous acid. It is chlorine and water combination. It is an aqueous solution of chlorine. An example of a tincture that you can buy would be iodine over in the pharmaceutical area where the bandages and band-aids and all are sold. You can buy you can buy iodine, which is the iodine lit in a pure alcohol tincture. Desirable qualities in a good germicide. Again, germicides are going to be things that are effective against large groups of organisms, not necessarily bacteria or viruses, but maybe bacteria, viruses, protozoans, etc., funguses. They should have rapid action and they should be effective even in low concentrations. They should be soluble in water or alcohol and have long-term stability. In other words, you shouldn't have to buy it and 10 days later buy some more of it, and 10 days later and buy some more of it. You should be able to buy it and keep it in your shelf or on your counter, in your cabinet for months or maybe even years. It should have a broad spectrum of microbial action without being toxins to humans and animals. In other words, you should be able to put it on your countertops without, blistering your skin, or if your dog happens to wander by, cause them problems. It should penetrate inanimate surfaces to sustain a cumulative or persistent action. In other words, it should be able to go into fabrics and carpets and those kinds of things. Should be resistant to becoming inactivated by organic matter. Again, earlier in this chapter, we talked about you couldn't use certain things on certain areas because it said not to use them with bodily fluids. It should be non-corrosive and non-staining. It should have both sanitizing and deodorizing properties. And it should be easily afforded and easily available. One of the things we've been going through, and not so much now, but about a year ago, a lot of these over-the-counter germicides were getting really, really hard to find because people were grabbing them up, and lots of people were grabbing a whole lot more than they needed because, well, there wasn't any here last week, so I need 4 bottles, but I'm going to get 10 because last week I couldn't get 2. So, germicides are evaluated in their terms of their effectiveness and destroying microbes in medical and dental settings. A high-level germicide kills endospores and can be used as a sterilant. An intermediate level germicide will kill fungal but not bacterial spores, resistant pathogens, and viruses. A low-level germicide will eliminate only vegetative bacteria, vegetative fungal cells, and some viruses. Basically, you can get both these and these at your local Target or Family Dollar. The difference is cost. These are going to tend to be more expensive than these. You can easily look at the label. The labeling that we have on products now will tell you the active ingredient. It will also tell you what organisms it is effective against. What factors affect germicidal activity? The nature of the microorganisms being treated. Are they gram-positive? Are they gram-negative? Are they spore formers? Are they viruses? The nature of the material being treated. Are you treating a granite countertop, or are you treating a fabric sofa cushion? The degree of contamination. Again, are there 50,000 cells there, or are there 50 billion cells there? How long should you leave it on? What is the time of exposure? Certain agents you spray on, you wipe down, and you're fine. Other agents you spray on and you spread them around, but then you have to leave them. If you've ever been into a fast food restaurant or a convenience store or truck stop restaurant, and there are no wet floor signs because the floor is not wet, but the floor still seems to have a sort of oily texture to it. When you're standing there looking at yourself in the mirror, fixing your hair, you feel your feet not really slipping, but sort of sliding just a little bit. Yeah, those are disinfecting agents that have a very long exposure time. They are generally phenol-based. Again, we'll talk about phenol in a later chapter. But phenol is phenolics are kind of oily, so they have a residue that takes a really, really long time to dry. Therefore, that agent is on that floor for a really, really long time. Personally, I wish they would leave the wet floor signs up until they weren't kind of slidey anymore. The problem is, most of the time, just about the time they're not slidey anymore, it's time to mop those floors again. And what is the strength and chemical action of the germicide? In other words, how strong is it, and what is it actually doing? Here are some very common agents that we have that you can get. Chlorine. It's effective against Mycobacterium tuberculosis, Entamoeba cysts, those are protozoans. Fa shows you the concentration needed to be effective and for the exposure time. Here is ethyl alcohol. Can be purchased at your local Dollar Tree or Dollar General or Family Dollar. Effective against Staphylococcus aureus, E. coli, and poliovirus. You see the concentration required. One of the things I noticed at one store, I'm not going to call the name of the store because I don't remember exactly which one it was, but the standard for alcohol is 70%. They were selling a 50% alcohol solution. So not even an alcohol solution that meets the accepted concentration. Hydrogen peroxide, 3%. That's what you're going to buy in the little brown bottles in, again, the Walmarts, Kmart. Well, no such thing as Kmart anymore. Walmart, the Target, and those types of stores. Quaternary ammonium compounds. These are referred to as quats. I guess it's because of the quaternary. They're called quats. But again, 450 parts per million will take care of Staphylococcus aureus, Salmonella type, smaller amount needed. Ethylene oxide gas shows the different agents that are the items that it can be effective against. Again, concentrations and time needed. Notice to get rid of using this to get rid of the influenza virus, you have to have an extremely large dose, and you have to leave it exposed for 25. That's an H for hours. Dilutions are a small volume of the liquid chemical placed into a larger volume of some solvent to achieve a certain ratio. That ratio is generally going to be given to you in parts per million. Sometimes the relationship will be given to you in percentages. Parts per million are going to be used for things that are effective in very dilute concentrations. Percentages are going to be things where the product has been added by weight or volume, and generally those are going to be a much higher concentrations. Length of exposure. Most compounds require adequate contact time to allow the chemical to penetrate and act on the microbes. Again, how is that length determined? It can be based on the composition of the material. The composition is smooth, solid objects are more reliably disinfected and those with pores or pockets that can trap soil. One of the things I tell students all the time, if you have true tile floors with a grit line or grout line between them, you may be doing a really good job of cleaning the tile and disinfecting the tile, but the grout line is much harder to do. You can use hydrogen peroxide to find out just exactly how clean your grout isn't. Pour some hydrogen peroxide on your grout line and see if it bubbles. And if it bubbles, that means you've got actively growing bacteria, fungus, and other items in that grout line. Large amounts of organic material can hinder penetration, and adequate cleaning of instruments and other reusable materials must precede the use of a germicide or a stimulant. In other words, if you're going to use particular items, you should clean them first before you apply the germicide or the steroid. Again, some common items that we use, the specific agent that is found in them, and the antimicrobial category they fall under. Lysol sanitizing wipes is dimethyl benzyl ammonium chloride. Don't worry, I will never ask you to repeat that. Look down here at Lysol disinfecting spray. The active ingredient is alkyl dimethyl benzyl ammonium saccharinate and alcohol. Or excuse me, that's two different ones. My bad. Alkyl dimethyl benzyl ammonium, which is a detergent. Saccharinate ethanol, which is a quat along with ethanol. Hand gels, some of them are ethanol based, some of them are detergent based. Eye drops for allergies. Sodium chlorate, which is a halogen. We haven't talked about halogen, but we will later on. So these are things that, again, disinfecting agents commercially available to all of us. And these are the chemical agents that can be found in there and what they are. Scope, ethanol. Scope is not an antiseptic mouthwash. Listerine is an antiseptic mouthwash. Hand sanitizer or hand hygiene since or with COVID. A study recently done followed 34 healthcare workers in a surgical intensive care unit. 24 of them were registered nurses, 6 were respiratory therapists, and 4 were nurse techs. During a typical 12-hour shift, 53% of them reported washing their hands with soap and water between 6 and 20 times. 41% of them used alcohol rubs more than 20 times, and 62% of them donned more than 40 pairs of gloves. Yowza. Now, pay attention to this. That study was conducted before the onset of the COVID-19 pandemic. Soon, there may be and probably will be studies that show healthcare workers and civilians have changed their hand hygiene practices during the pandemic, and we're going to look at how that impacted the skin microbiome. What these folks reported that this tile does not tell you is there were a significant number of people who were suffering from skin breakdown, and due to those skin breakdowns, they were suffering from infections. So they were getting small-scale infections in their hands because they were washing their hands so much. They were literally removing the beneficial bacteria that are on our hands that keep our hands as healthy as they are, plus removing the oils and things that our skin produces to keep them supple. That concludes this chapter. We will pick up with the next chapter next time. Thank you and have a great rest of your day.